folks, let's go ahead and take a look at example 6. So again, I have a rational inequality on the upside. I already have a 0 on this side of that inequality, so I don't have to subtract anything. I can go ahead and just start factoring out this denominator. So use any factoring method you want, AC method, guess and check, the little X method that I see all the time. Two numbers that multiply to 12, but add, multiply to negative 12, but add to positive 1. I'm going to be looking at positive 4 and negative 3. So let me just factor this, not refactor it, but factor it. I've got an x plus 4 and an x minus 3 on that denominator. Okay, so what I want to do whenever I have these rational inequalities, and I've got this 0 over here, we're going to set both numerator and denominator to 0. Now the numerator is a constant, right? And I can't actually get anything from 3 being 0. 3 isn't 0, so no extra or no x values come from that. But if I think about x plus 4 and x minus 3 being 0, well then I get that either x plus 4 was 0 or x minus 3 was 0. So I do get two x values that I'm ultimately going to put on my sign pattern over here. So I've got my two x values. Right, and now I'm ready to go add those into my sign patterns, collect some signs, and see ultimately where is that inequality less than or equal to 0. So where am I going to see negative symbols on the sign pattern, and where do I see zeros? So let's go ahead and make our sign, our x-axis, or really our smushed xy axis. So I'm going to put x down here, and then I'm going to figure out the signs for this inequality of 3 over, or not inequality, this rational expression of 3 over x plus 4, x minus 3. Ooh, and let me scooch that just a wee bit over. I'm seeing that's kind of going off your view. All right, so I've got that happening. Now I've got a negative 4, that's an interesting x value, and a 3, all right? And for both negative 4 and 3, if x was negative 4, this denominator zeroes out. And in a fraction, when the denominator is 0, that fraction does not exist. Similarly with 3, if x is 3, this fraction, right? If I take a look at that fraction, the denominator zeroes out, so the fraction as a whole does not exist. And then it's a matter of figuring out the signs that are involved, right? Do I put a plus or minus here, plus or minus here, plus or minus here? And you can do test points. So we've talked about this in a few examples. I could pick something like 4 here, 0 here, I don't know, negative 7 here. I can plug them into this fraction and just keep track of positives and negatives. But I'm to the point where we've done a few of these now. I'm going to do what I would consider the shorter or the shortcut method. So what I'm going to do is I'm going to look at the coefficients of the lead terms. So I look, coefficient in the numerator is 3, lead term over here is 1x squared, right? And if I just look at 3 over 1 in ratio, that is the number 3, but ultimately that's a positive number. And so whatever the coefficients of the lead terms are in this rational expression, that's going to determine your sign here. And then since this 3 came from a factor of x minus 3, and that was raised to the first power, that's an odd degree, we're always going to alternate around x values that come from factors with an odd degree. Negative 4, right? This x value came from the factor x plus 4. It's technically raised to the first power. That is an odd number, so it's going to alternate again. I'm going to alternate from negative to positive, okay? And just to give you a for instance, let's say, and I know it wasn't, but let's say this was squared, just so we can kind of have a counter example. All right, I still would have had the positive lead coefficient, but if I'm moving around this x value of 3, and we've got it coming from x minus 3 and it's squared, this plus here stays, but then this would not alternate. That would stay plus, and then since negative 4 was coming from a factor that had an odd degree, then it would alternate. All right, we just have to keep in mind that that way we move right to left, which is usually counter to how we always do these. We usually move left to right along an x-axis. But anyways, this was not squared. I can't erase that too very well. I think that's practically permanent in there. All right, so these did alternate. All right, now I want where this inequality is less than or equal to 0. So I want to look for negative signs on the sign pattern, and I want to look for zeros. So I can see a negative sign. I do not see any zeros in here. And that's because in order for a fraction to be zero, the numerator has to be zero, and the numerator is never zero. So this is really the only interval I want. So my answer is ultimately going to be -4 to 3 with parentheses. And you might be saying, well, you had an equals to symbol here. Why don't you put the brackets? And that's because -4 and 3, they don't actually provide, like if you plug them into this rational expression, the fraction doesn't exist. And if something doesn't exist, we can't include that in our write-up. So even though typically when you have a less than or equal to or greater than or equal to, you kind of expect brackets, these are going to be parentheses because these two x values are producing d and e's. All right, thanks so much. Bye.